Well, how's everybody doing tonight? You guys get any practice in over the last week? No practice? A little bit of practice?
Not as much as I'd like.
All right, that's good. Well, we are going to do maybe an hour of practicing together before our quiz today, so we get a little refresher here. Sorry, I'm stumbling all over myself. I did email you guys. You can let me know anytime this week if you wanted to do some practicing on Zoom. I am available. Next week's class is going to be a full review for the full 4 hours. So I was just creating the study guide. So I'll post the study guide tomorrow with the video, with this video and things that we'll do in class next week. So, but I just wanted to throw that out there. I'm definitely available. I know it's really hard. Usually we sit at a big table all together and we work on it together, and it's much easier to do it step by step when I can see your papers, but I can't see your guys' papers. So I guess those are the challenges that we're living with. Anyways, as far as the quizzes go, I wanted to share. So the quiz that we had last week was single contact, and it was basically this. It was this format exactly, actually. You know, what is the CPA and time of CPA? So this has to do with your R to M, your relative motion line. And then you have to create the triangle by finding them, the E to M line. And then if we change our RM line, what is our new course and speed? The E to R section of the triangle. So that is going to be the same format on all of your, or on your final exams. And what we're going to be like focusing on. So we're not going to focus on the other little things that they can ask you. There's a lot of information you can get, but we're just going to kind of focus on these 7 questions. Then for a multiple target plot, we're just going to add one more question, and that's, you do this whole thing, and in this question kind of becomes which one's most dangerous, and in that situation, are you the stand-on or giveaway vessel? And then what is going to be the new CPA of the least dangerous target? So if you turn for one target, how will it affect the other target? And that is going to be all of our paper plotting. So we're just focusing on these questions. But we're going to do a couple on the, let's see, this was in the homework section. Let's start with this one. There's the paper plotting homework 2. It was for week 5. We're going to start with this one today, and then we're going to do the other week 5 homework together before we do the quiz, so we can get some warm-ups. So if you are, I guess I would recommend doing it with me and asking questions along the way, so so that we get that muscle memory down. So I guess, yeah, that's our plan for today. We're going to do homework 2 and not that one. We're going to do, I guess it doesn't have a title, whatever that one is. Then we're going to do the quiz. So this is going to be a multi-target quiz. And then we're going to do our PowerPoint, which has the rest of the new information, or the kind of the rest of that theory information. And we're doing a lot about rules. So I kind of added in some of my other rules lectures. I don't know how much rules of the road you guys have had, but we'll go through all of that. And then for the homework tonight, it's a rules homework worksheet. But the answers and everything are on there, so should be a good study guide for you. Okay. Any questions so far about class or anything? All right. All right. Then let's get started. Okay. So I'm going to try to not lose my voice tonight. I was talking a lot last night. My voice started going, but okay. So for number 1, looking at homework 2, and this is a single contact, I think. So, so we're just kind of reviewing our steps. Here we go. So it says our ship is on course 340 at a speed of 22 knots. So I'm going to mark my heading flasher of 340. Let's see. So I'm going to say my own ship is at 340 at 22 knots. At 4:12, a pip is observed on your radar scope. The contact is bearing 320 at 10.7 miles. So we'll do 320. At 10.7. And we label that one R. Okay, so that's our R. And that was at 4:12. 6 minutes later, the contact is 321 at 8.4. Okay, so let's get 321 at 8.4. And we're going to label this guy M. And that was at 04:18. If both your ship and the contact maintain course and speed, determine the following. Then it tells us, well, I guess, what happened to this paper? So when I'm looking at this paper, I want to find what is the CPA and TCPA, what is the target's true course, target's true speed, and are we the stand-on or give-way vessel? So that's what we're going to work on. So I'm going to scoot over a little bit here. So to connect the first leg of our triangle is going to be R to M, our relative motion line. So we're going to connect R and M. And this is our relative motion line. So if we both maintain our course and speed, he will be passing in front of us, but getting pretty close. So what is that CPA? So are you guys using a triangle to find CPA, or what tool are you? Okay. So I put my pencil in the middle and I get my perpendicular line on that relative motion line. So this perpendicular line is on this R to M line, relative motion line. So you line that up, break your pencil. Just kidding, you don't want to do that. And that is going to be your CPA. So we'll want to measure that CPA. Mine's a little bit off here. I'm going to call it that. What did you guys get for your CPA?
Just one moment.
Yep.
One.
One?
Yes.
I got 0.8.
I got 0.8, but I think, where's my syllabus? So CPA is going to be plus or minus 0.2. So your one would have been okay. But yeah, I got 0.8. And then our next one is to figure out time of CPA. So for time of CPA, we walk down our 6 minutes down our relative motion line. So this technically, the 6 minutes, how far we've traveled in 6 minutes, we can call that our speed of relative motion, right? That using our 60D street. But some of the questions you'll see say, what is the speed of relative motion? But in my opinion, if you can get the time of TCPA, you understand what speed of relative motion is. So just wanted to explain that. Okay, so count by sixes here, 18, 24, 30, 36, 42, 39. So I'm going to call my time of CPA 0440. And this is going to be plus or minus 2 minutes. Okay, so did I do my math right on here? Louise, you got 433. That would be in between the 30 and 36. I'm definitely in between 36 and 42. Did I do that right? 12, 18, 24, 30, 36, 42. Oh, Okay, cool. Okay, so that is our first part, looking at the relative motion. So this is basically, we could get our speed of relative motion, direction of relative motion, but what we're getting here is our CPA and time of CPA for our relative motion line. Our next step is to figure out their ship, so the other ship's course and speed. So how we do that is we move over our own heading flasher line and we create the E. So we are basically creating the E to R, which is us. So down here, it says E to R. E to R is our own ship. So let's get 340. And then we're going to move that over to R. And draw in that vector line. So this direction of the line that I just drew is 340, and that's my own ship. Then I need to put in my speed. So how far am I going to travel in 6 minutes? Move the decimal over 1, and you get 2.2. So I'm going to find 2.2. And I get the other point of my triangle, and that is E. Okay. Guys with me so far? Got the E plotted. So now I want to figure out, what is this target doing? So my target's course and speed. So that is going to be E to M. So we're going to connect E to M. And this is a very small line, so we can have lots of room for error on this. Let's see, we always have to bring it down to the center so we can actually read the value. I got a course of 065. Captain Ron got a course of 062. What did you guys get?
I got 060, so 60.
Okay. Okay, well, it's ballpark. Okay. Again, this is such a small little line that I didn't actually connect the line. Oops. That's why we'll get different answers, which is okay. To get speed, you measure the distance, and in 6 minutes, you do the speed conversion, which will be easy. I got exactly 1.0, So I'll call it 10 knots. Check what Captain Ron had. Oh, 10 knots, yeah. Okay. So we were looking at R to M, and then we looked at E to M, which is them. So now let's figure out who is the stand-on giveaway. If they are two power-driven vessels, there's my heading, and that's their heading. So if we are two power-driven vessels, we are on the starboard side, so we would be the stand-on. We're going to go over all of those today. But maybe they are a sailboat or a towing vessel or restricted in their ability to maneuver or something like that. And we have to stay out of the way of them. The question asks us, what will be the new course if we decide to change course? So we have an MX. If we decide to change course at 0424. So our MX is a time, not a distance. So that the contact clears, we're looking for a CPA of 3 miles to port. So I want him to clear 3 miles to my port side. So this is my starboard side, this is my port side. I want him to clear 3 miles to port. So I want to bend this line to 3 miles on my port side. So I don't have a 3 mile ring, right? This is 2 and 4. So I'm going to create a 3 mile CPA on my port side. So somewhere along this line. All right, so this is going to be my 3 nautical mile CPA. And then here I already have my minute 24. So this is going to be my MX. That's going to be my point of execution. So I want my relative motion line continuing on here. Then when he gets to minute 24, I want that relative motion line to go to the 3 mile CPA. So we're going to draw in that new relative motion line. Okay. So this was my relative motion line. It went from R to M and continued on. This is my new relative motion line. And here's my MX. So I'm going to move this back to my M and create a new R to M line, that new relative motion line. So I'm going to move this new relative motion line back up to my triangle where I'm doing my math vectors here. So I'm moving from MX back to M. So I paralleled this one up to there. So this is my new relative motion line. Okay. What are you confused about, Sabrina?
I know my face always makes it look like I'm confused, but I'm not. That's just my face.
Okay.
I'm on like an unsturdy, like not unsturdy, but like there's a tablecloth on my table. So I'm using like something underneath to make sure that my lines are, that's all.
Okay.
It's a self.
Okay. Just you looked at the screen real confused. Okay.
I'm just like reading it and then making sure.
Okay. Okay.
mine's
As long
Thank
as you're good.
I do have actually a question.
Yes.
That was like 10 steps ago. Where did you get course, the target course of 65 and the speed of 10 knots again?
So that's E to M.
Uh-huh.
So when we look at E to M, let's use a little highlighter here. This is the line that we're looking at. That's our measurement.
Understood.
So
But how did,
if you just connect the two, they cross up here, right? We always have to measure a line by bringing it back to the center.
uh-huh. Oh, and you got, oh yeah, and that's where I got 671, but okay.
Okay, 60, I got 65, 62, somebody else got 70, that's fine. And then to get the speed, so each vector here, each side of the triangle has a direction and a distance. And that distance is going to equal speed because we have that 60 D street calculation.
Mhm.
So we measure that distance, which
1
is
mile.
1 mile. So in 6 minutes, we go 10, they would be going 10 knots.
Yeah, thank you.
Yep.
That's what I figured, but because I got 71, I was a little bit thrown off. Okay. thank
That's
you.
okay.
Or 071 is what I should say.
Okay. So, so we had our new relative motion line. We paralleled it back up to M. And now we want to figure out what our new course would be if we did not change speed. So if we maintained a speed of 22 knots, I'm going to get my 22 knots again. So E to R is 22 knots. We've measured that. So if I maintain this speed, but I want my R to be somewhere along this new relative motion line, I am going to swing this arc. I get just shy of that line there. And that is going to be what I call R prime, or the new R for our course, or RC, whatever you want to call it, really. So now we have a new triangle. Let me connect these. Now we have this new triangle. Can you guys pause for 1 second? I'm going to mute myself. Okay, sorry about that. Okay, so this is our new triangle that we're looking at. And so now we have the relative motion line that we like, right? This is the relative motion line that we've created for our desired 3 miles to port. So we created that line, and now I want to see what the new E to R is us, own ship. So I want to see what that new E to R line is. So I measure it, bring it back to the center. What do you guys get for your new course?
I'm sorry, I was trying to color code to we're doing the distance from E to R prime.
Yes. The distance is our same speed, 22 knots. So the direction, what's the direction? That would be our new course.
I got 017.
017, cool. I got 018,
Whew.
give or take.
$12. Hold on.
Okay.
Let's see. Let's try that one more time. Let's just slide it over. There it is. I got 017.
Cool. Perfect. Okay, so that's if we maintain our speed and we'd be changing course. Now I want to come up with a new triangle. The EM stays the same, but I want to stay on, oh, never mind, that won't work. I can't do a speed change. Oh yeah, if I slow down, he will not pass to port, he'll pass to starboard. But anyways, I'm not going to confuse you on that one. Okay. That's the end of that question. Did you guys get it? You guys, I think you guys followed along with me. Okay, let's do number 2. Wait, number 2 doesn't have a change course. Let's do what would be your new course if our original speed and all other factors? Let's do number 3. Okay. I'm looking at that homework assignment number 3. We have our own ship at 194 at 18 knots. So this is a good one because we're working on the bottom side of the scope here, which can be disorienting sometimes. But we're going to follow all the same steps. So we have a course of 194. And I'm going to call (194) at 18 knots. That's my own ship. At the times noted, a contact is observed on the radar scope. The following bearings and ranges. Okay. 1225, 233. So we'll get 233 at 10.5.
I'm sorry, what were the coordinates again for that one?
That was 233 at 10.5.
Okay. 223, 10.5.
R, what was that, 1225. Then we had 234 at 8.7. So we have an R and an M. That M was 234 at 8.7. So we're going to connect that R and M to get our relative motion line so we can get the CPA and TCPA. So there's our relative motion line. He's going to be passing behind us at CPA under 2 miles. But let's figure out what that CPA is. I do the right angle from the relative motion line. So I want to figure out what my CPA is in a distance. I got 1.1. How do you guys go on your CPA distance?
I got the same one, 1.1.
Okay, good, good, good. Okay, so then our next step is to figure out time of CPA. So we're going to use this 6-minute interval here and chug it along our relative.
I'm sorry, really quick.
Yeah.
Can you go over one more time how to use the triangle to get the CPA?
So you want, so your triangle, here we go. Our triangle has the long side and the 2 short sides. This 90 to 70 degree line is going to give us perpendicular to anything on this side.
Right.
So we're going to put that line on the relative motion line.
Got it.
And then we go from the center.
Okay, thank you.
Yep. Okay. Okay, so that's what I was doing. So our 6-minute intervals. Okay. Okay, so 31 plus 7, 31 plus 6 is 37. plus 6 is 43, 49, 55, and 1301. So we'll call that 58. So what do you guys get for time of CPA?
I would have like 1257.
Okay, I'm gonna call mine 1259. So I got my little ticket 1255 and then 1301, and then I put one in the middle. So that would be my 3 minutes. I just halved what my 6 minute was so that I can get a little bit more accurate.
Mhm.
So I'm saying it's in between 58 and 1301. I need to start drawing bigger on here.
$59. You said the margin for error for this part's plus or minus 2 minutes?
Let me give you a correct answer on that. Plus or minus 2 minutes, yes.
Okay. Let's make a note of that.
So I'm looking on the syllabus. We had our paper plot standards of accuracy. If you want to look at them.
I'm remeasuring my 6 minute.
Okay.
increment.
Okay. Okay. So we did our relative, our R to M's. That was this. Now we're gonna put in our E so we can get what their them, E to M, what the E to M lines are. So to put in E, we're gonna put in our E to R line first. So that is our direction of our own ship's direction of 194 at 18 knots. So I'm gonna get 194 and parallel that over. Okay, I ran off my chart here. Let's do it this way. Parallel it over to R. That was my line so wobbly. That's all right. And then I'm going to use my speed of 18. So that would be 1.8 in 6 minutes. Okay. So now I want to connect my E to M so I can get what their course and their speed is. I'm gonna have to do it this way. What is the new course that you guys got? Or the not new course, I'm sorry, the targets course.
Um, 115.
All right,
Did you get 120? Okay.
I got 120. Oh, let me see what they got. Number 3. They got 122.
Um,
Okay, so
I'm sorry. I mislabeled something and I am totally spacing out.
All right.
To get the new course, it's you measure from R to E and drag that over to the center, right?
So the R to E, that's going to be your own ownership data. So that's 194 and 1.8. So from E
Right.
towards R is the direction of 194, and then its length there is 1.8.
Right.
So then we have the E, and the M was already there. So now we can measure E to M,
That's what I'm doing wrong.
and that's them.
Keep going down. I got 121.
Sounds good. Okay, and then we want their speed, so we measure that distance. Which I got the same as last time, 10 knots, or 1 nautical mile there. Hey. So that was E to R is them.
wait, I thought E to M was them.
Sorry, gosh, you're right. My head's on vacation. Okay, E to M. Which is the target.
I thought
Okay,
it was knots, but very close.
sounds good. So then they say if your ship maintains, oh. Okay, so find MX at 6 nautical miles. So we have MX at 6 nautical miles and a CPA of 2. What will be our speed change and our course change? Speed change alone or course change alone? Okay. Okay, so let's do the course change first. We've been working on that first. So we are, oh wait. First we have to get our new relative motion line. So step number 1 on this one is to get a new relative motion line. So this guy goes within our 2 nautical miles. So we want a CPA of 2 nautical miles with an MX at 6. So here's 2, 4, 6. So this is going to be my MX. Then I forgot. Thinking ahead here. There we go. So if we're looking at our ships, I have the guy on my starboard side. I'm on his port side. So I am the giveaway vessel. He gets to stand on. I'm going to turn and give way. Or slow down. We're going to figure out both. So I want his relative motion line to pass in front of me. I don't want to cross ahead of someone that I have to give way to. So I'm going to bend his relative motion line from my MX to my 2 nautical miles in front of me. That's my pencil.
And you don't have to use the, because, sorry, because
Yes,
2
I already
are-
have a 2 nautical miles is already there. So I don't have to draw it in. So this is my new relative motion line. So I'm going to move this new relative motion line back to this M. I'm going to parallel it down.
Sorry, I'm comparing the new relative motion line, and mine is extremely off compared to what you have, so I'm trying to figure out what I did wrong. Let's get this out of the way first.
Where did you move it down to again? Like
So I went from the MX and I brought it back to M.
And then what?
And just draw it.
The other way. Okay. Yep.
The other way. Yes.
Wait, you went from MX to M?
I went from MX, which is at 6 nautical miles. Is yours at 6 nautical miles? And then to
Yeah.
2 mile CPA.
Yeah, that's what I did wrong right there. Okay.
Do you use the 3 mile CPA?
Yeah.
So that MX and CPA can change on each question. So I just want to look at it.
Relative motion.
So it looks better.
Looks better. Although I ended up from there, you'd measure MX to the 2 nautical mile ring.
Correct.
I ended up getting 5.5, which I'm not entirely confident in.
I'm not sure what number you're talking about there.
Measured MX to the 2 nautical mile ring.
So you just draw the line.
I'm skipping steps then.
We don't need a distance.
Whoops. Oh. All right.
So you just draw that line and then we parallel it to this M.
That's what I'm thinking. Okay.
Okay. So then to figure out our new course change, we have our M when we're going to create our new triangle. So this R is no longer the R we want. We have our E and our M, and we know our R is going to be somewhere on our new relative motion line, somewhere on the new R to M line. So we have to create where that R is going to be. If we remain the same speed, we swing our arc, and where that intersects, that is going to be our new, I have to connect the line, our new triangle. So we're going to measure that new E to R line to see what our new course is.
Say that again, Captain.
E to R prime,
Uh-huh.
the E to R of our new REM triangle is our new E to R is own ship.
Where did you get like the very last thing you measured to get 232? Where did you?
So I measured E to R,
Uh-huh.
and then I brought it down to the center,
Mm-hmm.
and I got 232.
I guess you're not really measuring E to R, right? You're just kind of putting the rolling plot there and then moving it down.
That would be measuring it.
Oh, okay. Okay. Sorry.
What do you mean you're not really measuring it?
I guess what I'm thinking is you're not measuring E to R like the distance from E to R.
We put that in with the distance. So we knew, we said it was going to be 18 for our 18 knots.
Yes.
So we know that the distance is 18.
So, but to get the new course, you'll put the rolling plot from E to R prime,
Yes.
and move it down to, back to the center.
Yes.
Not,
So
you know,
yeah,
okay.
I guess the other answer that Captain Ron had was 229.
I have 231.
Okay, cool.
I got 232.
All right, cool. Good. Okay. So now we're going to create another new triangle. So if for some reason we can't change course and we were to change speed, what would be our new speed? So we have option A and option B. We have two options. We want this guy to pass in front of us. So he's going to stay on this new relative motion line. That's the same. But if I want to maintain my course of 194, right? This was my course of 194, E to R. What would have to be my speed if I want my R to stay on the new relative motion line? That's going to be our triangle. It's a smaller triangle. So this would be our R prime. So we have E, R, and M. If we maintain our direction, right? So our course was 194. My own ship's course was 194, but I want to change my speed instead of changing my course. I want to maintain that course. So I'm going to slow down and let him pass in front of me. So how much do I have to slow down? I got about 8 or 8.5.
Wait, I'm sorry. How'd you get 8.5?
I measured this distance. So I'm measuring this vector here. So I'm maintaining my course of 194, but I want to see what speed I would be. So I measured this distance and I got right in between 0.8 and 0.9.
Okay.
So we convert that with our 6 minutes to a speed of 8.5. 8 or 9, something like that.
I think it's the conversion that's throwing me off. I followed all the way up to, I got 0.9. And then from there, that's where I lost it.
Okay, so just like everywhere else on our triangle, here we said this was 1.8, right?
Right.
Because we were doing 18 knots. So in 6 minutes, we would travel 1.8 nautical miles.
Right.
So we're just doing that math equation the other way. We're measuring this distance. We got 0.8. So how in 6 minutes, if we had our, our distance was 0.8, our time is 6 minutes. What is our speed? We can do that calculation. And because, so the rule of the 6 minute rule is with 6 minutes, you can just move the decimal over. Just like our ship, we had a speed of 18 knots. our time was 6 minutes. So our distance traveled, we moved the decimal place over to 1.8. So you move it over to a smaller number going to distance and to a bigger number going to speed. Did you do 60 D Street in Coastal Nav?
Yeah,
Or
although I
the-
did a slightly different format than everyone else did.
Did you just do D equals ST?
No, I did more of a box formation.
The
You'd
circle?
have 3 out of the 4 just fill in. Yeah.
That one. Okay. So if you get mixed up and can't figure out what it is, go back to the box formation, the 60 D Street. So we have a
Okay.
speed. We don't know what it is. Our time is 6 minutes and our distance was 0.8. I don't think I'm gonna throw a wrench at you guys and do anything that's not on the 6 minute scale, but it is possible. So a lot of times there'll be questions with the 12 minute on a 12 minute instead of 16. Or a half hour. But anyways, I'm not going to do that. Hopefully we're not going to come across one of those in our homeworks, but it's possible.
Okay.
Okay. So now we're going to do a multiple target one together. So let's practice that. And I think I decided let's do the last one on this packet, number 6. Wait, no. We have 5 and 6. Yeah, we'll do 5 and 6. Okay, so for number 5, we start out 0, 0, 0 at 17 knots, and then we have target A and contact B. So let's plot that information and then see where we are. So we had 355 at 11 nautical miles. And then 354. At 9.3.
What were the coordinates for the second target?
We had 062 at 9.8 and 063 at 8.3.
Okay, thank you.
Where the assignment is?
Like where the test
Where the
is?
test, yeah, I can't find it.
Is the test already on Canvas?
It is. You can take it.
What do you-
Oh my god.
where in Canvas? Is it in modules or
Yes, it's under quizzes.
under quizzes?
Quizzes multi-target.
Thank you. They're right here. Those are used. Well, the other side is. Okay.
I thought we were taking the quiz once we're done with this.
We are.
Oh, okay.
Yeah, it's on there. So the quizzes that I post, they're actually available starting midnight. So you can take the next quiz, the rules quiz, starting at midnight tonight. Whenever you want.
If I was an overachiever.
But I just wanted to have review available for you guys. So we'll do two. We'll do this one multi-target, and we'll do another multi-target, and then we're going to do the quiz. So hopefully we'll get to some actual material and PowerPoints tonight. Okay. So these are our R's and our M's for contact A and contact B. Okay, so I'm going to connect my R and M so I get the relative motion line for each contact. Okay, so I can see that both of these targets have a CPA within 2 miles. Right? So they're both concerning, but I want to know what is the most dangerous. So basically, which one is going to hit me or get within that 2 nautical miles first? So actually, in order to figure that out, I want to get my CPA and TCPA of each contact.
Can I ask a question?
Mhm.
I was jumping back and forth between that and then the homework, so I'm going to pull up the homework. Wouldn't you just by, maybe I've already asked this, but by just staring at it, knowing that contact A has moved, about 2 miles in 6 minutes, and the other contact is, oh, I guess they're about the same. Never mind. Like they're how quickly they've moved in 6 minutes. Wouldn't you, like, if you looked, if like, let's say contact A was 11 miles and then 7 miles, you would say, well, he's going a lot faster than contact B.
And that's the relative speed going a lot faster, right?
Okay.
Yes. That is correct brain thinking. Keep going with that. And then let's find the data.
Okay.
So same way of getting our CPAs. Okay, so I got my CPA for this guy at 1.4 and CPA for B at 0.9. So now I want to figure out the time of CPA. So again, that's very much related to the speed of relative motion and how quickly this is going to happen. Oh, and they're not, oh no, they are easy sixes. Okay, so 32, 38, 44, 50, 56.
Why did you go back in time?
Back in time?
Oh, you put 18? Is it 1900?
Oh, you're right. I don't know. It's 1900. 19. So that would be 20.
Where are we going? We don't need radars?
Oh, I was like, what is going on? 8.5. Okay, so this guy is going to get to our CPA a little bit 3 minutes before the other guy, give or take. So technically this would be our quicker one. But now I also want to see with these vessels, who is the giveaway and who's the stand-on, and see if that helps me figure out my most dangerous, if I have to give way for one or not the other, and see how that's going to affect before I decide what my new course is going to be. So I want to figure out the target's true course for each of these vessels. So I'm going due north, so I'm going to move my due north line. We're getting a very small triangle up here. Let's figure it out. I didn't put my own ship. Own ship. So I'm going to say my E and my M are the same. Very, very close. What does that mean? So what is E to R? E to R is own ship. E to M is the other ship. So if E to M are right on top of each other, what's happening to that vessel? It's not moving very quickly. You may even call it dead in the water. It's drifting very, very slowly because that E to M is so small. That's their vector.
But weren't they at R 6 minutes before?
Relatively.
Relatively, got it.
So R to M is the relative motion. E to
Okay.
M is their true motion.
Got it. I do remember that when you first went over what each thing meant before we even went to the plotting sheet.
So I'm going to call this one a dead in the water. Now I'm going to figure out R. Oh. 17. I messed that up already. So I created an E to R line on my contact B. And then I'm going to connect that E to M. So I got a target course of 306 and a speed of 15 knots.
Where'd you get 15 knots again?
E to M.
Got it. Yep. Measure that. See.
Can you show me how you got 306? Because I'm at like, hold on. I'm in the 330s. So
330s.
that would be it right there. I did mine backwards.
You were backwards?
Yeah. Wrong side of the ruler.
Ah, gotcha.
So if I just flip that. Yep.
So our situation here, we got a vessel dead in the water. A little Sea-Doo drifting away here. Another vessel on our starboard side. So if we're looking for whose giveaway stand on, I would technically be overtaking this guy, maybe, if he's just chilling there. Cruising down here, I'm overtaking him. I can pass him on either side. But this guy is on my starboard side, so I have to let him pass in front of me and turn and go to a stern or slow down. So I'm gonna bend my, what do we have here? We have a MX of 6 nautical miles, CPA of 2. So I'm going to bend this relative motion line in front of me, and hopefully that will make this guy's CPA also bend away from me. So let's draw that in. Here's 2, 4, 6. So here's my MX. Okay. Okay, so I have my new relative motion line. I'm going to bring that back up to my triangle. So I'm going to bring it from MX to M.
Is there some truth to like MX and M, like knowing that when you make your new relative motion line to bring it back up to M, is there like any relation? Like, is there a reason why it's named that?
Because it's the relative motion line, yes.
Okay.
Yes. Okay, so we have our new relative motion line in our triangle, and I want to figure out what my new course will be. So my speed was 17 knots. I think I still have that on here. E to R, 17 knots. And I'm going to swing that arc. So where it hits on this new line, that is going to be my R prime. So let's connect E to R prime. Get back to the center. Right, so this is that new relative motion line we moved up here. And now the E to R prime, that is going to be my new course.
Where did you, sorry, I was moving things around to get a better drawing. Where did you get, how did you do E to R prime?
We swung the 17 knots, E,
Oh, okay.
till it crosses our new relative motion line.
That's right. Okay. Oh, crap.
Okay, so now how is our new course going to affect target A? That's the big question. I want to know what the new CPA will be on the other target. So we're going to create our triangle back over here. So we are going to use our E to R is our new course. And create our E to R line over here. Let me do that. Okay, so I had my E to R line here, and I moved that vector up to the other E that I had. So this was my E, and then I created my new R. So this course I had was 049 at 17 knots. That's the values I've just put in there for that green line. Okay, so now I want to know what will be the new CPA. So where do I put in my new relative motion line for target A? So my R to M, this is the weird one because it's dead in the water. So our triangle isn't a triangle, it's a line. So our R to M line goes here, but it doesn't go directly here. We have to move our R to M line back to MX. So we need to plot where MX is going to be on this relative motion line. So here my MX was just before 1938. So where's this target going to be just before 1938? We'll call it right here. Yes, I eyeballed that a little bit. So this is my MX. That's where that target's going to be when I change course. So I'm looking at my R to M.
Why wouldn't you just put MX on the 6 nautical miles?
Because that target has a different relative speed than that target. So we changed course when this target was 6 miles away. But when we did that, this target wasn't quite 6 miles away.
Okay.
So we did it at that instant in time. So we use finding the MX on the other least dangerous target, we use time. We'll always use time. So my relative motion line on the least dangerous target here, I'm going to transfer to my MX. So I have my,
I have a quick question. It's not really pertaining to what's going on. It's just a general question about the plotting.
go ahead.
Okay, so when you get your first R, you get your M, and then you have to plot your E. How do you know on which side of the line to put it on? If you put it above or below? I don't know if that makes sense.
Yes, so your let me put it this way. So your E, right? You have your R and your M. Your E, you're making it E2R. So
Yeah.
E2R. So whatever your course is, if your course is 180, then you're going E2R at 180. If your course is 045, you're creating that E2R at 045 or 180. You're creating that vector going towards R.
Got it. It's just what's throwing me off is that we're usually doing a lot of things that are O, and it's going straight up, so it's easier to visualize, but questions that are like 210 or 270, it's harder for me to, I have to like reverse it.
It's disorienting when you're using the bottom of the scope.
Okay, cool. Thank you. That's all I had to ask.
Okay. Okay, so this is our new relative motion line for the other target. So same way to get our CPA. (90 degrees to the new relative motion line. Bumping into things here. I did this with a marker, so it will be give or take here. 5.6.
Where did, I understand that you use perpendicular from the triangle, but what is the significance of the new line, the pencil marked line?
That's the point of the CPA.
How did you get that distance from MX?
It's not from MX.
Okay.
It's from the center. So what is my closest point of approach?
Okay.
That's, yeah. This is my new CPA.
I see. Okay, so there is no significance from CPA to MX. It's just the new CPA. Got it.
If I wanted to know what time that was,
Mm-hmm.
sure, you'd measure it from MX.
Okay.
But don't worry about that. Like I said, there's so much information you can pull from a plot like this, but we are just going to focus on these questions. Try to keep it a little bit simple. I know, looking at it, you're like, how is this simple? Okay. Okay, any questions on this? Okay, so it is 7:45. Let's take a 10-minute break here. We've been working for a while. If you want to keep practicing, you can do number 6. I'll start plotting number 6 so I could just do the end of it for you guys before the quiz. But yeah, let's take a 10-minute break. I'm going to do a little review on number 6 of this homework assignment, and then we'll do the quiz.
Perfect. Can we take a 10-minute break and then have a couple minutes to get a jump start on 6?
Yes, we can do that. So we'll come back at 8 o'clock. Cool.
There's nothing you really do with the speed of your own ship until later, right? When you're reading.
That's how you plot E.
Okay, that's what I'm kind of like asking. Like, you don't use that until a little bit later. Like, first off, you plot.
First off is R to M.
Okay.
So you get CPA, TCPA just by doing R and M.
Okay. Yep.
And then the triangle.
Okay. I think someone had already asked this, but why do you not put E on the other side of RM?
Because you're going E to M, or
Yes.
E to R. When you're doing your first triangle, right?
Yes.
Yeah,
But how come,
you're creating the E to R line. So when we look
how
here,
come E wouldn't be on like the left side of the line? Because that would still be E to R.
so we have E here, right?
Mhm.
And our course is 310. So if you draw it over here, you want to go E to R. So if you put it here, your E to R is going 130.
I see.
So E towards R, if it's going that way, is over here. But
Mhm.
E to R is going to be the 310, what we're creating.
I see. It's E to R is like our direction.
Correct.
Okay. You probably just already said that, but like, okay.
That's okay. So Louise just asked, I'm going to answer his question here. On the plot or on the homework assignments, there the questions are phrased a little bit differently than how I phrase them. So I try not to use as many acronyms and just kind of make it you know, what is the target's true speed and the target's true course? What is your new course? What is your new speed? Instead of coming up with the acronyms, just because we already have a lot of acronyms. So I'm just trying to minimize, to try to simplify it a little bit. But yes, the homework can be confusing in that way. So I guess, let's see, on this one, it says, what is the DRM CPA and SRM TCPA? So those first 4 questions, like we've been doing, only has to do with that R to M line. So R to M is our relative motion line. So they're asking DRM, what is the direction of relative motion? So that's, what is the direction of this relative motion line? So if I was to plot that, I would just continue this relative motion line and say our direction of relative motion was 210. Our direction of relative motion on this one was 0.45. So that's just saying the direction of relative motion. And then SRM is the speed of relative motion. So we had DRM, SRM, that's direction and speed. So for speed of relative motion, you just get your distance from R to M and say, what is that speed? And now remember that speed isn't the speed of the vessel, it's the speed of relative motion. So I don't really like how they're both called speed. I like the time of CPA better. How quickly are they going to get to you? So I think what you take from the speed of relative motion is how quickly they're going to get to you. So what is that TCPA? So direction of relative motion, speed of relative motion, CPA, TCPA, all have to do with just that R to M line. I'm only asking you to get CPA and TCPA because I think that means more as a navigator than it does direction of relative motion or speed of relative motion. When I look at direction of relative motion, I basically am looking, are they going to pass in front of me or behind me? And sometimes I'll say that when I'm doing the plots with you guys. I'll say, oh, they'll pass in front of me, they'll pass behind me. I could see what it is. So it's not, you know, exactly your CPA isn't your direction of relative motion, right? Your CPA here is 0, but your direction of relative motion is 210. But as a navigator, what are you going to do with that knowledge of direction of relative motion is 210? It kind of, I don't think, makes more practical sense. I think what makes practical sense is our CPA is 0. He's heading straight for us from wherever he is. So it's not exactly equal, but as the instructor, I decided to focus on more practical CPA, TCPA, instead of direction or speed of relative motion. But that is what's on a lot of the homework problems. But again, try to focus on these standard questions. That's what the test is going to be on. And I feel that this is what is more practical knowledge of what you're pulling from this information. There is so much information you could pull from this chart or from a radar plotting transfer sheet. So I'm just trying to get down to the nitty gritty of when you're underway, what do you want to know, how to have your collision avoidance awareness. So I guess that's my soapbox there. What was another acronym? CPA, closest point of approach. Oh, so then they had DTM and STM. So that is true motion. That's going to be your direction of true motion and your speed of true motion. And that is what I just call the target's course and speed. What is the target's true motion? Their course is 358. What is the target's true motion speed? 25 knots. So it's so we do that when you look at the answers or something at DTM or STM. That's what the target information is. What is the true motion of that target?
I think what I asked was incorrect because there's what is DRM and what is CPA all on the quiz.
On the quiz? Let me look it up.
Or maybe that's the homework. Sorry, I was looking at the homework.
Yes, on the homework. So that's
Isn't that one the same then if it's at like A and B, like what is the DRM? And then the next one is what is the CPA? Is that one and the same?
So I am just skipping over this DRM. I don't think you need to know that. And I don't think you need to know speed of relative motion. I think if you understand how to get the CPA and understand how to get the TCPA, you understand both of those.
So the answer is the same for A and B as also for like C and D for on the homework?
No, it's not the same answer. So the answer I have is 210 and CPA was 0. Speed of relative motion, I didn't even calculate because we use that speed of relative motion, right? Our distance from R to M is our speed of relative motion. We use that to get our TCPA. So if you're incorrect on your speed of relative motion, then you're incorrect on TCPA. What did I say my CPA was? 0727, 256, and 24. So they are, lots of numbers there, but I'm just trying to simplify it. So don't get hung up on the acronyms or what DRM is or SRM. I just want to try to make it simple. Okay, that was kind of standing on my soapbox for a little bit there. Okay, let's get back to this and then we'll dive into the quiz. Okay, so here I have a target R and M, target R and M. Both of them have a CPA of 0. So I'm concerned about both of them. Target B is going to be, has a TCPA a little bit sooner than target A, as well as target B is on my starboard side, meaning I'm probably going to be the giveaway vessel to target B over target A. I'm more concerned with things on the starboard side of me because that's my, who I have to give way to. So I plot my new course to let this guy have an MX of 5 nautical miles, passing 2 miles ahead of me. I have a new course of 0 to 1. So now, how is that going to affect target A? I need to figure that out. So what I'm going to do is have my new course that I want to plot back over to this triangle. So here's E to R prime. So I want to make E to R prime exactly over on this triangle. So I'm going to get my plotter. I have there's E to R prime. So I just created the line. Now I want to know the speed, which was our 18 knots. So that is going to be my new R prime. So I've just created the same line. So I've moved this line and put it here for my new E to R prime. So now I have here my relative motion, my new relative motion line was my R prime to M, right? My new relative motion line, R prime to M. So here, where's my R prime to M? That is going to be my new relative motion line. So I'm going to make this one in green. My new relative motion line, if I change course, oops, I'm just going to make it small. Didn't mean to confuse you there. So that is my new relative motion line. Now what I want to know is what my CPA is on this target now. So I'm going to move this new relative motion line, just like this one is, to MX. So we had R prime to M, and then from MX, we created it again. So we have R prime to M. I need to figure out where MX is going to be and create the line again. So here our MX was at 12 minutes. It was actually at 5 miles, but our 5 miles was at 12 minutes. So I'm going to see here at 12 minutes, that is going to be my MX. How am I going to write this? MX. At that 12-minute mark. So I'm going to get my draw it like this. R to M line, bring it back to the MX. Look, I jiggled. So that is my relative motion line for this guy. So let's look to see how that because our brain does this logically in our heads, but it's hard to visualize. So if I'm here and this guy is going this way, so my blue line right there is their target's true course. So if target doesn't change course or speed. So if I'm going this way and I'm going this way, we're headed on this collision course, right? So that's why our relative motion line is 0. But if I turn all the way to my new course of 210, and this guy continues on, his relative motion line, he's going to start going this way relatively, because I've changed course so much that he's going to be cruising along that line. So mental check, that makes sense. But I want to know what my CPA is. So I use my triangle to get 90 from the center on my new relative motion line, which is pretty much going to be right when I turn. I'm going to be just turning away from him. So my CPA my new CPA is 6.4. They got 6.2. That's okay. Okay, any questions on this? Correct, that's the new CPA for the least dangerous target. The new CPA for the other target we created, right? That was our CPA of 2. We wanted a desired CPA and we created it. So we're trying to figure out what is the CPA? How is that going to affect the least dangerous target or the other guy? Cool. Okay. So it is about time to get started on the quiz. Let's bring up the quiz. Let me bring up the quiz real quick. Well, I keep wanting to share this, so let me bring it up in my book. Okay. So our quiz asks us, we have 2 contacts, not exactly the same as this, obviously, but we have 2 contacts, plot R and M for both of them. And then our questions, what is the true course of both contacts? What is the true speed? So we're getting, that true course and true speed motion. What is the CPA? Or which contact is the most dangerous? So on our notes, we have that, I don't have it printed out, I don't think. But if one vessel doesn't have a close CPA, then they're not dangerous. If both vessels have a close CPA, which one is going to get to that CPA quickest? So then you decide which one's most dangerous. And then they say, if you have an MX of 6 miles and a new CPA of 2, what will be your vessel's new course? So same thing like we've been doing in our practice here. We have an MX. This one was of 6 miles, but a CPA of 2. We move that RM line back up to our triangle to get our new course. what will be the new CP? So we get our new course, and then we get a new CPA. Sorry, new course. Let me slow it down here. So we got our RN line, we get our new course. That E to R prime is our new own ship line. So we're bringing that new E to R prime line back to the other triangle, the other vector triangle that were created. So now we have our E to R prime, then we can get R prime to M. So our R prime to M, we created with our desired CPA. We're seeing what our R prime to M is on the other CPA. So we get our R prime to M, and then we need to move it to MX, but we don't know where MX is. So we use time. When was this MX? And then I'm going to put that on my new relative motion line. Then I create my new relative motion line, and I can get what my new CPA will be, perpendicular to the new CPA line. The quiz also asks about option A and option B. If you were to change speed, would that give you a better CPA for this guy? So if I was to change speed, let me get a different marker here. My E to R would be that line. So when I go to E to R, I get R prime over here. And then I have my relative motion line. Trying to come up with another marker. Purple. My R to M would be going like that if I was to do my speed. I'm going to leave this up as a reference if you want to click back to it. Or use your own notes. Again, this is just an exercise of you going through the whole motions, you know, start to finish. So go ahead and get started on the quiz. And I'll check back in at like 9:15. Yeah, I'll check back in about 9:15. But I'll be here. I'm going to leave this up. I'll be here, so shout out if you have a question. How you guys doing? It was a tough one.
Okay, I have a quick question. Okay, so for this, the CPA and stuff that they want on the question, now normally what I would do is I would have the ship or whatever that's gonna hit me pass behind me. It seems like it wants it to pass ahead of you in order to turn. If you're turning right, it would pass ahead of you, right? Is that what they want us to do?
Yes, you want the vessel that is the that you're giving way to pass in front of you. So you go behind the other vessel. You don't want to cut in front of a ship. You want to
No. It's because, yeah, I understand that. But what I'm trying to say is that when you make your CPA, I mean, the way I set it up is if you turn left, it'll pass behind you. But because there's two, and I'm assuming the majority of the time they want it to be ahead of us to turn right. That's what's throwing me off. I'm putting it behind instead of ahead.
Yes, and it's weird because it's on the bottom side of the scope, but you want it to pass ahead of you so that you will go behind them I'm gonna try to do it with my level
Okay.
targets here. Okay,
Got it.
so you're over here. Vessel is over here that you're targeting for. Other vessels over here. If we turn to the left, no, this is turning to the right, their CPA is going to go in front of us.
Yeah.
If we turn to the left, their CPA is going to go behind us.
Yes.
But with a vessel to starboard, we don't want to cut in front of them. So if we're looking at it up here, even if they are leaning towards crossing astern of us, we don't want to cut in front of a vessel that we have to give way to. If we have to give way to this guy, we're going to turn to the right. So we move our dividers always clockwise. And they're going to pass ahead of us. So that new relative motion line is going to be crossing our heading line.
Okay, got it. Thank you.
How far did we get? Wait, are you guys seeing my screen? Did I just explain that and you weren't even looking at it? Oh, yeah. Sorry, Lucy. I'm using my boats here and you're not even looking at it. Okay. Yeah, so our situation looks like this, right? So we want him to pass ahead of us and we're going to turn to the right. So there, the CPA, the new relative motion line, is going to be on this side of the 2 miles. So yes, he's passing this way, but that means we're cutting in front of someone that we're giving way to. So just like up here, even though they might be passing slightly astern of us, we never want to cut in front of that vessel. We're always going to go to the turn right and pass their stern. So same thing down here. Okay, did anyone submit their quiz yet? No. All right, guys, so I know most of you guys are still working, and I want you to continue working and submit the quiz with your own answers. And I'm going to show you my quiz. So this is the quiz. Oh well. Our multi-target quiz here. So as I was kind of showing us earlier, we're on this course and we want them to pass in front of us. So we are going to be turning to the right, and we realize that turning to the right, we get a bad CPA for target B. So slowing down, so if we maintain our course and we just slow down, that allows these 2 vessels to pass in front of us. And we don't have to worry about it. So how much do we slow down? So where were you guys getting stuck on this? So I can review it for you or explain. I tried to color code here so we could explain my lines, but I want to help you guys understand. So where was a hiccup for anybody?
I messed up pretty early on my CPA and my lines got all mixed up. So I had to start over.
Okay. When I was just doing this quickly, I put the CPA on this side too, because I don't know, it made more sense in my head. And then when I plotted, I was like, oh, that's a turn to the left. I don't want to turn to the left. I want to turn to the right. So I did it again. So very easy mistake to do. But yeah, you always want to turn to the right. I don't know. All right, guys, is anyone still there? We might have lost everyone. Oh, okay. Well, I am going to stay on, but I feel like we're losing people here. So we are not going to go into the PowerPoint, kind of little announcements here. We're not going to do the PowerPoint today. We are definitely out of time. So I don't know, I'm either going to post the video of me explaining the PowerPoint, but I'm thinking of, no, I'm just going to do the PowerPoint tomorrow or next week. Yeah, I'm just going to do it next week so I can answer your guys' questions and stuff. And then we'll also do the study guide and more practice questions, kind of a practice final exam next week. So we'll go over that. I'm going to stay on here for a little bit. This is my answers to the quiz. I'm happy to explain it to you. Just submit the answers that you got, or try to get the lines. I know there's a lot of lines on the page and stuff. But also remember to submit your homework assignments. You don't have to submit the rules of the road homework assignment because we did not get to that today. But also, if you guys are working on it sometime this week and get stuck on something, let me know, and I'm happy just to jump on Zoom and work through some problems with you guys. So I am available and I want to help you understand it. So yeah, email me, let me know. What else? What else did I want to say? I don't know. I guess that's it, I think. I think that's it. I'll be on here. Yeah, I think that's it. Okay, so Louise, you were asking, everything was clear until the new CPA. Okay, so I am going to explain my new CPA here. So I created a desired CPA here. So MX6, CPA 2. So I created a relative motion line, a new relative motion line for my desired CPA, and put it over here so I could get it to my triangle. Then I had option A. Well, I can't say it, option A. One option was to change course, and one option was to change speed. So and those both going to be from E. So I want E to R prime, but that R prime has to be somewhere along this green line, which is my new relative motion line. So my new relative motion line is here, and I want my R prime to be somewhere along it. If I maintain speed, my speed of 18 knots, I swing my my arc over at 18 knots clockwise to starboard. So I swing that arc over, and wherever it crosses that green line, that's going to be my R prime for my course change. So this orange line is going to be my new E to R for the course change. Option B is to maintain my course. So this is my original course, right, of 210, to maintain that course, but slow down. So where does that, if I maintain this course, where does that course line cross my new relative motion line? That's my R prime for a speed change. So this is my E to R prime for a course change. This is my E to R prime for a speed change. So going to see how things affect the other triangle. We started with the course change, right? So our course change, wait, transferring to target B is definitely where it can be confusing. Yes. So E to R, right? E to R is the ownership. So E to R, we're going to take this course and this speed and transfer it down to this guy, E to R. So I just transferred this direction and speed, and I get E to R prime. Now my R prime to M is my new relative motion line. That R prime to M, where I just created that E to R prime, is my new course. So R prime to M is the new relative motion line. I have to create an MX that I can draw it from. So my MX was about 49. I said it was 1449. So there was my MX. And I paralleled this relative motion line from this MX. And I got a very tight CPA. So that course change would not work for me because it puts me in a sticky situation for target B. So let's look at option B. Yes, the R1 to the new M. That's your new relative motion line, right? R to M relative motion. So if we do E to R prime for our speed change, E to R prime, speed change, we're just going to put this vector to this vector. So we already had that E to R. So we're going to do E to R prime, which was that 8 knots. So now I have a new R prime. So now I have a new relative motion line, R prime to M, that I put back to my MX and create that new relative motion line. Again, we're following R prime to M for the speed change. And put it here, and that's a much better looking CPA. So then when we look at it, we're here, this guy's here, and this guy's here. If we turn to starboard, this guy, but then we get into a sticky situation with this guy. So if we just slow down, we let these guys pass in front of us, and then we could continue on our way. Was that a kind of clear explanation for you, Louise? Right on. No, submit whatever you have. You could be looking at mine, you could use your notes, you can use all this information. Just submit whatever information that you've come up with. Again, I'm not trying to torture you. This is just a, you guys need to be practicing too.
One question. This seems to always throw me off.
Mhm.
How would I even word that? So going back to CPA,
Mm-hmm.
trying to figure out, and this doesn't have to be for this can be for any of them, but trying to figure out the degrees.
Mm-hmm.
For this problem, we're going down.
Correct.
We're going toward the lower end. So when trying to figure out the degrees of the CPA, am I also looking on the lower end of the radar chart plotter?
So degrees of CPA, are you talking like the bearing of the CPA, which is a
Yeah.
possible question, but we haven't really been doing it in my lecture? Is that what you're talking about though? It's not a
Probably
question.
not.
It's
So-
not a question on the quiz.
No, but it's needed to its course. There we go. The course for the CPA.
Yes, what is the new course?
No, like way before that.
Wait,
Just the CPA itself. From once you have that plotted, and then looking at. Oh, my terminology is horrible right now.
you could like lift up your thing and like show me in the camera. I could try to look at that.
So starting over on this, how do I angle this so I can see it as well, so I know what I'm pointing at? Trying to see. Okay, so the CPA for one of them being great. I'm not even sure if you can see that
Yes.
right there. To figure out the
The time?
no, not well, yeah, I guess it's part of the time. The degrees, am I going up or am I going down on the chart? Because for the problem, we're going down. We're not up oriented.
Correct. So for the CPA, let me go back to share screen. So for the CPA, if you're kind of asking, like, is it going to pass behind us or ahead of us? That's what I like to think about when I'm thinking
Right.
about where that CPA is. So, so we have R to M. That CPA is passing directly through us. So it's
Yeah.
neither to the north or to the south. It's CPA 0 collision course. This
Right.
guy's CPA is wherever it's closest. So if you're trying to find the bearing of it, it's going to be, 255 or something. But you don't
Okay.
really need to find that bearing of it. But for the 0 ones, it's neither upscope or downscope. It's collision course, just 0.
I'm adding things that aren't even there. Well, that'll explain my confusion. Okay.
Yeah, I wouldn't worry about the bearing of the CPA.
Okay. All right, let me go back to this then.
Okay, so I have a question.
Yeah.
Because so far I've done this problem about 3 times and I keep getting a different answer every time.
Okay.
So I'm not really understanding what is going on, but let's see, so far for A, which is let's see, contact A, the true course. Every time I keep getting a different one, I keep getting 113, 117. What's the
I got 108, but the book says the answer is 112. So I feel like you're in the ballpark.
okay?
Why they're different? Are they in different places, or are you?
I don't know. I mean, this is what I have so far right here. I don't know if you can see.
Hold on a second. Okay, let me get add pin. Let's see.
Yeah, I don't really understand.
Okay, so we have this guy. So E to R, E to R. Okay, I feel like you're on E to R. You've got everything right so far. I mean, I think the lines are in the right place. I see your E to R's. So then you have your E to M and your E to M. Yeah, I think you're on the right track there. So let me go back to share
It
screen.
doesn't really match what you have, though. That's the problem. That's what I'm confused about.
For target for both of them. Is that what you're
Yeah.
asking? So
Yeah, like the course and everything. I don't understand why I'm off so much every time.
I guess my answer is that it's such a small line that mine can be off, give or take a few. Yours can be off, give or take a few. The book says the answers are that, so I was off a little bit, but I think you said you were close to that one. And then
Yeah, I had the first one I got was 113. And I was going 11 knots, and then I had contact B's true course was 288, and their true speed was 15 knots.
That's good.
And then
Good.
which contact's most dangerous? I got A,
Yeah.
and then the new course would be 240,
Yeah.
and then the CPA for B would be 1504.
1504.
Like time-wise?
Oh, the CPA for B. Yeah. Yes.
So all of those are correct?
Yes.
Okay.
But
I guess what I'm having trouble with, or I'm stuck with, is the it's asking the time of maneuver, which would be for A, but since it's so small, I can't really eyeball it. It's kind of hard to like.
so yes, it's asking for that MX. Where is MX? The time of maneuver.
Yeah.
So yeah, this was at 1446. And then
I
we
was
had
gonna put like 40, like 48, because
Yeah.
it's so close.
yeah. That's
Does that work?
yes.
Oh, okay. 14, 14, 48. Okay, and then contact CPA. Shoot. How much time do we have to turn the quiz in?
You could turn, let me see it on the thing. I think it says midnight, but let me see. Is there a due date on it?
Okay, so these are all right. Okay, I wasn't going crazy. Oh my god, I almost had a.
So the due date on the quiz is tomorrow at midnight.
Okay, because the one that I told you that I had the answers for, I know I had them all right. The only thing that was throwing me off was the MX to M, because it's so close. I
Yes,
wasn't sure
right
if it
here.
was. It seemed. Yeah. That's what was throwing me off.
Yes. I see why that does, but yeah, just try to so it's a little bit different than ones we've done in the past. But I don't know, just try to keep it simple. Like we have our MX and our new relative motion line, and then you just bring it back to M. Doesn't really matter that they're close.
Was the CPA for B close to like 1504 for time? Was
CPA
that-
for B, I got 1507. So let's see. CPA for B, 1504 was right here. This was my CPA, and then 1510. If we're looking at the original CPA, or are you looking at a new CPA?
I was looking at the because it asked.
It doesn't say either way. It's not a question. We're not looking for any.
It said, what will be the new CPA of the least dangerous contact?
So that's going to be a distance.
Oh, so it's not asking for time, it's asking for the distance?
Correct. So
Oh,
TCPA
okay.
is a time. Just regular CPA is a distance in nautical miles.
Distance. Okay, and then okay, that's what I was confused about, because when it said CPA, okay, cool.
That's a
Got it.
distance. Yeah.
Well, if it's asking for the new CPA of the least dangerous contact, wouldn't it be exactly 2 miles? If
That
you're
was our
going off of-
most, that was our most dangerous contact. So they said, what will be your new course change? So target A is our dangerous contact, right? We
Yeah.
said that. So if we change course, we get a new course line. So this E to R prime
Yeah.
is
got it.
is my new course of 240. That's what you said you got too. So
Yeah.
then we bring that vector, that E to R prime vector, highlighted in orange here, down to this line, back to this E, the E of the B triangle. So now we have E to R prime, that same orange line, that same direction, that 240
Oh, okay. So
at
it's
at
asking
18
based
knots.
off of that maneuver.
Correct.
Okay, cool.
Correct.
That's what I was leaving out, because I thought it was asking time, not distance.
So yeah, so we have our E to R prime, and then we have R prime to M. That's our new relative motion line. So we put in our new relative motion line, and we could see that if we make this course change, that new relative motion line gives us a CPA of 0.1, 0.2. I think the answer said 0.4. Either way, it's real small.
Okay, got it. I was leaving that out. That was all.
So
Cool.
then what will be the new CPA if you do a speed reduction? So you do new e to r prime, that gives us r prime to m, this pink line, as our new relative motion line. So that looks way better than this one.
Yeah.
So that speed reduction is going to be our option to choose.
Now that new speed, so far you can get it by, what is it? Oh my. What I was doing is I was getting the e to where is it? So e to RML. So it would be from
Yes.
the e to
Yes.
RML point. I was measuring that. That would be the new speed, right?
Correct.
Well, what I was confused about is 'cause when I
maintaining
was-
on that original course line. Right, you maintain your course, E to R.
Yeah.
Okay. So where it crosses the RML.
So it was E to R crossing the RML.
Yes,
So it would be from the E to the RML line.
correct. So that little yellow one right here. Can you see that? So this was that relative motion line that we created at mile 6 with a CPA of 2. We brought that
Yes.
relative motion line to M.
Yes. Mm-hmm.
And if I maintain my course, my original course is this guy at 210.
Mm-hmm.
Where does this new green line cross my original course line? That's going to be my R prime for speed change.
It just looks really weird on mine. Hold on. E to R prime. So you would measure it from E to where again? The R primed?
Where it crosses this green line along your original course line. So you have your
Okay.
new course line, that's the one in orange. Then you have your original course line.
I got 0.8, which is 8 knots.
Correct.
Okay. Cool. All right. That was the last bit of confusion I had.
Okay. And please, guys,
Cool.
feel free to let me know if you guys have questions throughout the week. I know it's a holiday weekend and everything, but
Yeah.
I'm happy to help out. Or yeah.
Would you be available tomorrow around, I'm out of class, but around 2:30?
Yeah, I can do that.
Cool. I will be on Zoom around then because
All right, I'll
it's like
email
I
you
start
a
to get the
Zoom, a
concept.
new Zoom link.
A new Zoom link? Okay.
Yeah.
It's like my problem is I start to get the concept, I go through it, no problem. And then it gets to that one question, either whether it's by myself or the orientation is flipped
Mhm.
and everything just goes out the window. And it's like, I get the CPA and it's all gone. I'm looking back at old work and it's not transferring. So
Yeah. Okay. Well, yeah, we can do some practicing tomorrow
yes.
if that works out. But yeah, I'll send you a link tomorrow morning.
Okay. Thank you so much.
You're
All right,
welcome.
I am definitely going to be calling it a night though.
Yeah. We're done now.
Yeah. All right.
All right.
Again, thank you. And I will see you tomorrow around 2:30.
All right. Have a good one. See you guys.